Hi, so I'm David Jedynak, Chief Technology Officer from Curtiss-Wright Defense Solutions. I actually live here in Austin, but I arrived here in Austin at about 8:45 this morning on a red eye from LA, which will make sense in a few minutes. Anyways, mine is a lot less technical, and it's actually more about the warfighter. And it's a little bit personal, and you'll see that here in a minute. So let's go way back, the B-29 Superfortress. That aircraft carried a number of radars. And this was right at the end of World War II, going into the first few years after World War II. The really tall guy wearing the suit that's different, that's my dad. And he was a radar technician who was fixing the gear. And then eventually they said, hey, we have to have these guys on board. And they said, well, even though he's enlisted and he's not an officer, we'll put him on the flight crew because we're supposed to have a radar operator. And that's what the Strategic Air Command says what to do. Anyways, what's interesting about that is the Warfighter Burden was a lot of information. That in the upper right there, that was my dad's first computer. And it literally says AAF, which is Army Air Force, which is what he enlisted into and came out of the US Air Force. That's a computer. That was a computer to calculate all the different stuff. And then you look at the bottom right, and that was the setup for that's the APQ-13. A lot of stuff that was on the aircraft just to do a high altitude bombing radar. And then those manuals there, those are actually, they're in my suitcase. I meant to bring them. That's his radio fundamentals and radar electronic fundamentals that he had to go through this whole thing, and it's deep, just to fix the stuff. And then that other manual sitting in the middle is his Strategic Air Command manual for running the stuff, and it is painstaking. In fact, I was flipping through last night and went, oh wow, there's a whole chunk of pages missing because you probably taped them up somewhere. And it was like, here's like 17 switches you have to flip just to get the thing on. A lot of warfighter burden, right? This is early days of all of this stuff, and again, there's the computer in the upper right. Anyways, he came out of the Air Force, and then he was off and did some GI Bill stuff, and then got a doctorate at MIT, and there's his first computer on the left, so off at Lincoln Labs, the Whirlwind, and there's his last computer on the right, an iPad. So when we think about that, and we talk about embedded tech trends, when we talk about our industry, what's happened since 1950 to 2018? It's miniaturized, we've converged functions, we've increased value. I'm not going to go about performance and MIPS and memory and all that other stuff. The value, it's gotten more valuable in the way, however you want to metric it. And it's driven by COTS technology and standards and ecosystems. It's a commercial endeavor that drives this forward, for the most part, fairly uninhibited. It goes based off of market desire, market push, and market need. When we look at our industry, specifically the defense industry, and we think about all the stuff, I took a bunch of pictures of a bunch of radios that, like all these need GPS, right? And they all get them from a little, a serial GPS interface. But that big pile of radios, all of those things are separate boxes, a lot like the APQ-13 Mickey radar that my dad was using, or the APQ-7 Eagle radar that he was using. These big sets and these big separate things with lots of dials and knobs and readouts. It's a separate function. The future is a lot like we see in our own commercial markets, when we have our phone, et cetera. It's convergence. We're converging functions. We're doing more with the processing that we have, and we're saving space, and we're saving function, and the functional burden. So this is the warfighter's future. Then CMOSS, and I'll talk about it in a minute, that's the C4ISREW modular open suite of standards, which includes VPX and Victory and FACE and something called MORA, modular open RF architecture. This is something done by CERDEC, who is a member of the board of directors of VITA, pushing these standards forward. So why is this important? When I look at this, a lot of buzzwords go around, and we talk about this in the technical communities within government acquisition, and we talk about it with government folks, we talk about it within the primes, we talk about it with suppliers like Curtiss-Wright, we talk about this is really great, it's modular. right? There's modularity, and oh, look, we could have the same blade in multiple places. Oh, there's commonality. Those are big buzzwords. What's interesting about those is that those are really like engineers and buyer's goal. The engineer is like, I want a modular, open system architecture, and it's good. There's goodness to that. When you look at a buyer and he says, commonality, great, I get volume pricing. That's the best thing. And then the logistics guy says, yeah, it's great. We just order one of that spare and we use it all over the place, right? But none of those talk about the warfighter and the warfighter's burden. And the warfighter's burden is really the real goal. That's why all of us that work in the defense industry, what we do is about the warfighter and enabling the warfighter. So when we think about our technology trends and what we're doing and what we're pushing towards, we need to think about, lower operational and training loads, fewer knobs and dials to turn. If all the radios are in a chassis of software-defined radios and not each one has its own on switches and bit buttons and key fills and all that other stuff, we're reducing their burden. We're saving space. More room for bullets and water, right? That's what's really important to the guys. They're like, okay, those radios over there, they're just taking up room. I could have had another guy in my squad sitting next to me, but instead there's a big stack of radios there. Training. As I showed you, there's a training operator's manual, and frankly, the current ones, like the Dagger manual, I think the abbreviated one is like 300 pages. The full one is like 800 pages, right? The technical manual for using the handheld GPS receiver. So the fewer number of these things, the better we can do on the warfighter burden of training and the cognitive load of what he needs to think about. The other thing too is, and we talk about this all the time, right? With VPX, we've got this wonderful, slot profiles and module profiles and backplane profiles, and we talk about how we should do it, and we say, hey, let's build our products so that we can take one out and drop another one in 3 years later, a couple of Moore's Law cycles later, and ta-da, there's an upgrade. That's great. Engineers love that. Acquisition folks are like, hey, that's great, maybe I can solve my obsolescence. But what really matters is the warfighter says, wow, that new threat that just came that requires more horsepower, that solves for me because all those other people who do that, they did it. And they got it in there for me and they just dropped it in and it just works. I had an interesting conversation yesterday with a nephew who was in Marine Force Recon in Afghanistan, and we were talking about a couple of things, and he said, I ended up just buying like these Garmin things because the Dagger was just so incredibly complicated to use. And he's using commercial GPS in his missions in Afghanistan because it was just easier to use. And that part of that's the Dagger's old, right? And it hasn't been replaced for a very, very long time. So they want it to just work. They want it to be better. They want it to be easier. So when we look at CMOSS, so there's the big acronym, C4ISREW Modular Open Suite of Standards. Here's what's really interesting about it, right? If you step back and you look at other industries and convergence of standards and things, and it all starts to come together. If you've worked in the software world or the consumer electronics world, which I have, or the film world, which I have, there's all these things happening where the workflows get easier, the friction gets lower, you get things more integrated. It used to be in cars, we had all the dash top ornaments, right? We had the GPS receiver and the satellite radio receiver and the little Bluetooth thing. They all sat on your dash, a bunch of appliques, and then suddenly they're all integrated into your dashboard. And it's all seamless integration now with Android or with Apple or whatnot. We want to have that pull together. So when we look at CMOSS, it's a real effort to say, here's what the network fabric should be. And it's open standard. Here's how we do central radio clocks. We got a brand new profile for radio clocks that's in Vita. That's all about how do we get the timing out to everybody and not have all these separate things. How do we make sure everything is as software defined as we possibly can so that when that new threat comes and somebody figures out how to jam our waveform, we can tweak it a bit and then overcome it. And then it's payload modules. And even more interesting is when we first looked at CMOSS, it was like, well, there's software defined radio blades, there's processor blades. And you realize, wait a minute, if we take off P2, sorry if I dive into the tech, but the P2 connector on the 3 VPX, you say, well, that's where the Vita 67.3 connector goes. Just leave it off on the processor, and they're the same thing. It's a radio or it's a processor card. And then you have an open standard ecosystem, right? We're all working within this, whether it's Curtiss-Wright or our competitors, it's the primes, it's the labs, we're all working around the same standard. And that's what happens in other industries, is people work together. You don't see BMW making their own roads or their own gas. That would be silly. Everybody comes together to do the same thing. Everybody comes together to do HDMI, right? Everybody comes together to do USB to make sure that there's that commonality of standards and all these modular standards that are then used so everybody else can go off and do their secret sauce. Here's the problem. Culture always beats technology. You could have the greatest thing ever. How many people remember VHS versus Betamax, right? Betamax was clearly technologically better, but it lost. Why? It was a cultural thing. There's lots of different stuff in the culture of the adoption and how it was pushing, and it seemed very proprietary, where everything else seemed open, and the lower quality technology won. And that's happened multiple times in lots of industries. So just because it's the right technical solution does not necessarily mean it's going to be the right acquisition solution. And if we look right now at CMOSS, we've got great technical value. It's wonderful. We've got great warfighter value because it can converge all these things down, but we're running into the friction or the inertia of legacy systems that we haven't put the money in to change them over. Risk aversion, it's new. How do you get over that? The concepts, systems engineers that say, I have a function, I put a box around that function. There it is, and I acquire it. And then acquisition silos. Well, this guy, he does foo. That's what he sets up to acquire, and this guy does bar, and they can't ever do them together, or better, chocolate and peanut butter. Nobody figures out, oh, peanut butter cups, right? They don't do that. There's acquisition silos. That's the cultural part of all of this. So here's what's interesting. I'm going to do a quick little story. So back on that B-29, where my dad was not an officer, and the captain didn't want him on it, but he says, well, I have to. First time he was there, he said, the captain said to him, Radar, I don't want to hear from you. I don't want you on the intercom. Nothing. Zilch. I flew all these missions over Japan in World War II. I don't need radar. I did just fine without it. So a bunch of hours later, they're heading home. They're coming down the eastern seaboard. They have to get back to Topeka, Kansas. Lots of drills going on. They're doing the photo flash bomb stuff. And there's a massive storm front coming in all along the eastern seaboard. And my dad's listening in to the chatter in the cockpit, because he's on the intercom, he's just not talking, about the fact they're deciding whether or not they're going to have to land somewhere and stay out the night before flying back, which would be bad mark for everything. But the storm was so bad that it would have crashed the plane. It was bad. So finally, my dad kind of pipes up. He goes to the navigator, says, knowing the captain's listening, and he goes, so I see this, and I see it on the radar, and I see a hole. There's a hole there, and what do you think I should do? And the navigator says, well, I don't know, do you think we could get through it? And he goes, yeah, it's big enough to get through, and it's there, but we got to do it now. And can you tell the captain? And the captain goes, Radar, I'm listening. What have you got? And he says, okay, there's a hole. And they go through, they do the thing, the lightning hitting both wingtips at the same time, whatever. Anyways, they make it back to Topeka. And at the end of that, they get off the plane, the captain goes up to my dad and says, welcome aboard, Radar. Go ahead and keep talking, right? But here's what's interesting about that, right? That's a story about a right technology. It was there, and there was a cultural pushback. Oh, we don't want to do it. That's not how we do things. That's not how I've done it before. He spoke up. He said, evangelize, right? Those of us in the tech industry, we understand evangelizing tech. Speak up, evangelize it. And then you've got to commit to action. You've got to commit one way or another to supporting that standard and pushing forward with that standard. And even if maybe people aren't quite there yet, right? It's not quite if you build it, they will come. That's a real hard one, especially in our industry, because it takes a while for them to actually come, because it's government acquisition. But you've got to commit. You've got to lean forward into it and make it happen. And thus, in those of us in the COTS industry, that's what we do. We have our IRAD to spend money and to commit and to take that chance and get through that storm and get the crew home safely. So our commitment. So Curtiss-Wright, we've committed at this point, and we have product already that was part of CMOSS in terms of some stuff that was going on, but we've committed that we're going to support this standard. And there's new module profiles, and we're going to support those. There's tweaks to existing profiles, and we're going to support those. And there's areas where we're saying, maybe it's something we haven't really looked at before, but it's important. And we see this, and we see the vision from CERTEC I2WD, and to give kudos, that's spread to other folks with SOSA, is spreading out farther with that same sort of standard idea of the same sort of modularity and saving on the space, et cetera. We're committing to that with product, with IRAD, with commitments. So we've spoken. I spoke about this a couple of years ago in Houston, I think we were, but now we're committing with product. I want to make sure everybody understood that. At the end of the day, what's important is our customer is the warfighter. And sadly, the reason I just came from LA is because I was just at Miramar National Cemetery because unfortunately my dad passed away last week. And strangely enough, I had already planned this whole deck and I was going to do this whole talk and then, there we go. So anyways, I want to open up to any questions. I know this is not a technical thing. I'm a chief technology officer, but the main thing is technology isn't always right. You've got to stick out. You've got to push. So thank you very much.